Okay, let's go through this word problem and application problem of the logistic growth function given here. All right. So they've given us a function or equation which is f of t equals 97,000 divided by 1 plus 1939 times e raised to the power negative 1.7 times t. All right. Now, what does this function model? It models the number of people who have become ill with a particular infection t weeks after its initial outbreak in a particular community. All right, so what it does is it will tell us how many people can be expected to be infected t number of weeks after the particular infection or particular disease was first identified. All right. The question is, how many people became ill with this infection when the epidemic began? So T over here is the number of weeks. It's a variable which represents the number of weeks since the first outbreak of the illness. So think about the COVID, all right, the COVID infection, all right. So at a certain point in time, it was first detected, first identified in a particular individual. Maybe that was the first individual who got infected by the illness. So from that time, from that day, since the first person got infected when the disease was first identified, how many people would get infected after T number of weeks? All right. So if somebody asks how many people would be infected after 2 weeks, then we need to plug in 2 into the T in the formula, and whatever this calculates to will be our answer, will tell us how many people we can expect to be infected. All right. But what they are asking us here is how many people became ill with this infection when the epidemic began. That means at the starting of the outbreak, all right, how many people were infected on, let's say, day 1, right, of the outbreak. So that's what we have to find. We have to tell them. So when we talk about when this infection began, that means T is equal to 0. All right, T is equal to 0. So to solve this problem, what we do is we have f of 0, all right, we plug in 0 for T, and then 97,000 divided by 1 plus 1939 times E raised to the negative 1.7 times 0. All right, you have to plug in 0 into T in the equation. And let's see what we get here. We have f of 0 equals 97,000 divided by 1 plus 1939 times E. Negative 1.7 times 0 is 0, correct? And any value raised to the power 0 is always a 1. So what do we end up with here? We end up with 97,000 in our numerator, and in the denominator we just have 1 plus 1939 times 1, right? E to the power 0 is 1, and 1939 times 1 is just 1939. So I'm going to get rid of this times 1. We don't need it because it's just going to give us 1,939, correct? So we will end up with 97,000 divided by 1940. Whatever that comes to is going to be the number of people infected initially when the epidemic began. All right. When we divide 97,000 by 1940, we will end up with f of 0 equals 50. All right. So the answer is the number of people who became ill with this infection when the epidemic began was 50. All right. So that's the final answer. So 50 people were infected when the infection began, or they became ill when the infection first started, when the infection or when the epidemic started. Right? Now, question number 4 is a word problem on the growth and decay models of exponential functions. All right. So it says here the function a equals a sub 0 times e raised to the power negative 0.01155 times x. It models the amount in pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put into the vault. If 400 pounds of the material are placed in the vault, how much time will need to pass for only 40 pounds to remain? So this particular problem is a decay model. So we start with a certain amount of the material, and then over time it decays and is reduced to just 40 pounds. So the question is asking, how much time will it take for the material to be reduced from 400 to 40 pounds? And we have to use this particular function, the equation in this function, to solve the question, all right, to solve for the time that they are asking us to find, all right? Now, if we recall from our lecture, the decay model, or whether it's the growth model or the decay model, it's the same function, except that in the decay model, the rate of growth will be negative. All right. So let me just start with going over the function of the growth and decay model. All right. We had A equals A sub 0 e raised to the power k times t. That was the function that we had learned about, right? Now, A represented the final amount, whether it's growth or whether it's the decay model. A always represents the final amount at the end of a certain period. A sub 0 represents the initial amount that we start with, again, regardless of whether it's the growth model or the decay model. E is, of course, the natural base, a constant value, which represents the natural base of this exponential part. K represents the rate of growth. All right. Now, if it is a growth model, then K will be a positive value. If it is a decay model, it will be a negative value. And T represents the time over which the item or the entity will grow or decay, right? So in this case, in this particular example, what we have been given was A equals A sub 0 E raised to the power negative 0.01155x. So they have given us a value for K, which is negative 0.01155 rather, just this, and then X is actually the T. So instead of writing a T, they have given us X. All right, so X and T are represent the same thing, time in this case. So let's look for the values that have been given to us. All right, now over here, A represents the final amount, and the final amount in this case is 40 pounds. All right, it's 40 pounds. That's what A is. Then A sub 0 is the initial amount. So what we start with of the radioactive material is 400 pounds. So it's going to be A sub 0 equals 400 pounds. All right. And then, of course, K is given to us. X is what we have to find. So let's start plugging in the values. It's going to be 40 equals 400. All right, I replaced A sub 0 with 400 and A with 40. And then we have E raised to the power negative 0.01155, and then X has to remain as is because that's what we are solving for here. Okay. Now, what do we do first? We first have to try and simplify this, all right? So let's see what we can do. We have to, first step is to isolate the exponential part. That means the exponential part is E raised to this power, all right? So we have to isolate it. It has to be by itself. We don't want any appendages to E. So here we have the 400. We have to remove that, all right, by dividing both sides by 400. And that way we can isolate the E. All right, so we'll have 40 over 400, all right, equals E raised to the power negative 0.01155x. All right, and we can simplify 40 divided by 400 further, okay, and write it as 1 over 10. All right, so it'll be 1 over 10 equals E raised to the power negative 0.01155x. All right. Now in this step, all right, we have to take the ln of both sides. All right, to solve for x, we have to take the ln of both sides and write it as ln 1 over 10 equals ln of E raised to the power 0.01155x. All right. What do we do in the next step? We have to take the right hand side of the equation and apply the power rule to bring down the exponent part, all right, and bring it down to the left hand side of ln E. So this is how it's going to look after we do that. It's going to be ln 1 over 10 on the left hand side. On the right hand side, it's going to be negative 0.01155x 55x times ln E. All right. So now we have ln of 1/10 again on the left hand side. Now ln E is a 1. So we can write this as 0.01155x times 1, right? So anything times 1 is anything. So I'm going to remove this, all right? And just, oh, well, why remove it? Let me just write it as the next step, all right? Negative 0.01155x, all right? So then we go on to the next part to solve for x. We just divide both sides by the value of k, negative 0.01155x, and that gives, sorry, not x here. So we have this and this divide on the right hand side, and we have x equals. Now you have to use your calculator, all right, to evaluate ln of 1/10 divided by negative 0.01155, and this comes to ln of 1/10. If you run that through your calculators, it should give you negative 2.3026 divided by negative 0.01155, and x will therefore evaluate to approximately 199.35 years, which you can round it to 200 years perhaps, all right? Approximately 200 years. So you have to write your answer in a sentence form and say that it will take approximately 200 years for the material to be reduced from 400 pounds to 40 pounds. All right, so 200 years will pass before the item is reduced to 40 pounds. All right. Now question number 5 is a word problem with application to calculating compound interests. The first part is about calculating compound interests at finite periods, and part B, which says compounded continuously, is about compounding the interest or calculating the interest on a continuous basis. So there are two different formulas we have to apply, as we learned before, but let's go through it and first try to extract the data that we will need to work these problems. It says use the compounded interest formulas A equals P times within brackets 1 plus R divided by N, the whole thing raised to the power N times T, and A equals P times E raised to the power R times T to solve the following. Find the accumulated value of an investment of $10,000 for 5 years at an interest rate of 5.5% if the money is compounded monthly. The first part, all right? So to answer the first question, we will need to use the first formula given to us. All right. So let's look at the formula. Let me pull up my pen here. So we have A equals P times 1 plus R divided by N raised to the power N times T. So A represents the final amount that we need to calculate. It says find the accumulated value. That means the value at the end of however many years. P represents the principal, in other words, the amount we started with, which is equivalent to A sub 0 that we used in the previous questions. All right, but here, because it pertains to interests, we just use the word principal amount, which is represented by P. All right, so we have to know what P is. Then we have to know what R is. R is the rate of interest. We have to know T, which is the period of time over which the interest is going to be calculated. And N represents, just a second. N represents the number of times the amount will get compounded. All right. So let's extract the value. Principal amount is $10,000. So I'm going to write here 10,000. R is the rate of interest, so 5.5. Now that 5.5% has to be converted to decimal. So 5.5 divided by 100 should be 0.055, all right? So we have to convert this percentage to decimal when using it in the formula. T is the number of years, therefore 5, and N is the number of times per year it's getting compounded, all right? So it says here it's compounded monthly. So how many months in a year? 12. So the number of times it will get compounded is 12. So N is going to be equal to 12. So now that we have extracted all the data from this problem, let's just plug those in to the formula. So A equals, P was 10,000, so it's 10,000 times 1 plus R is 0.055, so 0.055 divided by N is 12, right? 12 times, it's going to get compounded. And then the exponent values are N times T, so 12 times 5, right? So it's 12 times 5, which is going to be 60, all right? So let's work this step by step. And again, I strongly recommend that you show each and every step, because if you go wrong in the final answer, you still get a chance of earning partial credit, all right? You don't get 0 for the problem, but you get some credit for every step you completed correctly. Okay, so 1 plus 0.055 divided by 12 is going to be, let's write it like this, 12 plus 0.055 divided by 12. So here I am adding a fraction to 1. So you have to follow the steps of adding fractions. And then 12 times 5 is 60, right? Then let's continue with it. Simplify this further in the next step. I have 10,000. Now this bracket 12 plus 0.055 divided by 12 is 12.055 divided by 12. And when we do the calculation on our calculators, I got 1.005 within brackets raised to the power 60, right? And then in the next step, we will get 10,000, and then 1.005 raised to the power 60 calculates to 1.3157. All right, and then 1.3157 multiplied by 10,000 would be $13,157. All right, so the accumulated value of the investment for $10,000 for 5 years at an interest rate of 5.5%, if compounded monthly, will amount to $13,157, right? So that was the answer for part A which is a calculation compounded monthly. For compounded continuously, we have to use the second equation given to us, which is A equals P times e to the power r times t. All right, so let's write that down. A equals P times e raised to the power r times t. Again, this is similar to the problem that we had solved previously. Only thing is, instead of a sub 0, we have used p, all right, because we are working with a financial application problem, compound interests, where we call the initial amount the principal amount, all right. So let's, the same data applies here. So we will have A equals P is $10,000. All right. And then we have E, all right, natural base E, which is, again, it's a constant value, right? R is 0.055, and T is 5 years, right? So 5 years multiplied by 5. So there is no n here, all right, because it's getting compounded continuously. Okay, that's taken care of by E, the base of the exponent that we are using. All right, so now let's continue. A equals 10,000, and then 0.055 times 5 will give e raised to the power 0.275, and then we will have 10,000, and now I'm putting the 10,000 in brackets, e raised to the power 0.275. You have to do this calculation on your calculator. There should be a button for e, all right, so that should be raised to the power 0.275, and that is a value 1.3165. all right, and when we do this multiplication, we will get an amount which is $13,165. Okay, so that's the final answer, and you can write this, the answer, because this is a word problem. You can write the answer in a sentence, the final answer. Now, the last question here is about solving a system of linear equations, but in 3 variables. Now, previously, in another course, you may have worked with systems of equations in 2 variables, x and y, where you had to solve, you had to find values for both x and y. But here we see 3 variables, x, y, and z, and we have 3 different equations. All right, so we have to use all 3 of these equations to come up with values of x, y, and z. All right, so how do we go about that? The first step is pick any 2 equations and reduce them to 2 variables. All right, so we are going to find a way of coming up with equations, 2 equations in 2 variables first. All right, so what I'm going to do, and just follow the steps what I do here, I'm going to pick, you can pick any 2 of these equations, and the goal is going to be to eliminate one of the 3 variables. All right, so I see over here outright that it'll be easy to eliminate the z, because we have a minus c and a plus c. So what I'm going to do is, as the first step, okay, let me pull up my pen, we have x plus 4y minus z equals 20. And then I'm going to pick the first and the second equations. And we have 3x plus 2y plus z equals 8. All right. And how am I going to eliminate a variable? By adding the two equations. All right. Now, if we add the two equations, we can see very easily minus z and plus z will subtract and we can eliminate them. All right. So I'm going to have 3x plus 3x is going to be 4x. 4y plus 2y is going to be plus 6y. And minus z and plus z is going to be 0z. So that eliminates the z variable. And on the other side, 20 plus 8 is 28. All right. So we have one equation now in two variables. We have reduced two of these equations. We have used two of these equations and we managed to reduce it to two variables. Now we have to get another equation in two variables as well. All right. So again, pick any one of the two equations that we worked with before and the third equation, all right, in the original set, which wasn't used. All right. So I'm going to take the first one, x plus 4y minus z equals 20. So let me work this on the other side. So we have x plus 4y minus z equals 20. And then the third one here, all right, which is 2x minus 3y plus 2z equals negative 16. All right, now we cannot just eliminate things outright. We have to do some manipulation. We have a minus z here and a plus 2z. All right, we have to eliminate the same variable. All right, if we have eliminated z the first time and the second time also, we have to eliminate z. We don't have a choice here. All right, so to make this minus z minus 2z so that it'll negate, it'll zero out, we have to multiply this entire equation with a 2. All right, and let's do the multiplication now. We will have 2x plus 8y minus 2z equals 2 times 20, 40. So we have to multiply all of these terms on both sides of the equation by this 2. All right. Now the bottom equation, we do not have to multiply by anything. So we just write it as is. So it's going to be 2x minus 3y and then plus 2z equals negative 16. Now we just go ahead and add. 2x plus 2x is a 4x. 8y minus 3y is a positive 5y. And minus 2z and plus 2z is a 0z. So that goes away. And 40 minus 16 is a 24. So now we have two equations in two variables which we are going to use to solve for x and y first. All right. So what I'm going to do is I'm going to take this equation and this equation, which are now in two variables, x and y, and let's solve them. So I'll have 4x plus 6y equals 28. And the second one is 4x plus 5y equals 24. All right. Now, we have a 4x. All right. We have a 4x and a 4x. If we add them up, it'll be 8x. All right. So that doesn't eliminate any of the variables for us. But if I multiply, just a second. If I multiply one of them with a minus 1, then I can get a minus 4x, which will eliminate the x variable. So what I'm going to do is I'm going to multiply the second equation with a negative 1. All right. So The first one stays as is, so 4x plus 6y equals 28. And the second one, since I'm multiplying by -1, is going to become -4x minus 5y. All right, again, all the terms have to be multiplied by -1. So we are going to get -5y equals -24. So 4x minus 4x is 0x, so that goes away. 6y minus 5y is positive 1y, and 28 minus 24 is positive 4. So we just got a value for y, which is 4. All right, so let's write that down somewhere here. Y equals 4. All right, so this is going to be our answer set right here. So we just found y. To find x, all we have to do is plug in 4 into y in any one of these equations, all right, and solve for x. All right, so we'll take the first one. Okay, so 4x, I'm just taking the first one, you can pick any one of these, plus 6 times 4, y we now know is 4, so just plug that value in for y in any one of the equations, equals 28. So 4x plus 24 equals 28. So move the 24 to the other side. So we have 4x equals 28 minus 24 is a positive 4. So x is going to be 4. Divide both sides by 4. We will get x equals 1. So now we have found the value of x also, which is x equals 1. So now that we know the value of x, we know the value of y. You can take any of these equations above from the original set and plug in a 1 for x and 4 for y and solve for z. That's it. So x, so let me just first write the equation. X plus 4y, and let me make some space here. Now let's work it here. X plus 4y minus z equals 20. And we know x is 1, so I'm going to write 1 plus 4 times 4, right? That's the value of y I plugged in, minus z equals 20. So 1 plus 16 minus z equals 20. So 17 minus z equals 20. So we will have negative z equals 20 minus 17 is positive 3, right? I moved the 17 over to the other side. So it becomes minus 17 on the other side. So 20 minus 17 will be 3. So divide both sides by -1. So we will have z equals -3. All right. So z will have a value of -3. Now the last part, I will leave it to you, but you must do that. All right. You cannot just stop here. Just plug in these values of x, y, and z that you found and cross-check, verify that they satisfy all these equations. So you're going to plug in 1 for x, 4 for y, and -3 for z in each of these equations and make sure that the equations are satisfied. All right, that they equal to 20, the second one equals 8, and the third one equals -16, right? So that completes question number 6. It just involves solving for x, y, and z all the variables in the system of linear equation of 3 variables.